All right, so in this video, we're going to cover the part 2 questions, numbers 25 to 31. Let's go to 25. So for 25, they want us to construct an altitude that goes from vertex J to ML. And altitudes are perpendicular to the opposite side. So we got to make sure that we construct a perpendicular line from point J that is perpendicular to ML. So that's really what they want us to do. Okay, so for number 25, we are supposed to construct an altitude. Now, an altitude is a line that connects a vertex and is perpendicular to the opposite side. So what they really want us to construct here is a perpendicular line that connects the vertex J and the opposite side. So it's a line that goes from J and is perpendicular to ML. That's what they want us to do. So let's take our compass and we're going to put it on point J, and we want to open it so that when we swing an arc, we intersect 2 points of ML. All right, so swing my arc. You can see I got 2 points of intersection. One here and one here. The next step is to take the compass, put it on one of those points of intersection, keeping the compass setting the same, swing an arc, and then put it on the other point of intersection, swing an arc, take a straight edge, and connect J to where those arcs intersect towards the bottom of the picture there. So you want to connect J to that point of intersection there, and then that's your altitude. And we're done. All right, number 26. They want us to find the area of a sector. So for these kinds of questions, you need to remember this formula. Okay, it's the area of the sector over area of the whole circle equals the central angle over, it says central angle over 360. And what we're going to do is plug into this formula and solve. So area of a sector, that is unknown, so I'm going to label this X. Area of the circle, I can figure that out. They gave me the radius. I know that the area of a circle, let's work that out here in red. Area of a circle is pi r squared. So if they're giving me the radius as 4.5, it'll be pi times 4.5 squared. And since they want this in terms of pi, I'm just going to square the 4.5 in a calculator. Got my handy dandy TI 84. TI over everything. Don't really mess with Casios. So we get 20.25 pi. So I'm going to plug that in here for the area of the circle, 20.25 pi. The central angle, they gave me that, right? In different words, they said that determinant state in terms of pi, the area of a sector that intercepts a 40-degree arc of a circle. So by them giving me the measurement of that arc will be equal to the measurement of the central angle. So that will be 40 over 360. Cross multiply this and solve for x. So they want this in terms of pi. So you're not going to multiply by that pi. Just do 40 times 20.25. That gets you 810. X times 360 is 360x. Divide both sides by 360. This cancels out. That was 810 pi. Forgot to bring the pi over. So 40 times 20.25 pi is 810 pi. So just divide 810 by 360. Don't include the pi because we want our answer in terms of pi. So we're going to get x equals 810 divided by 360. So 810 divided by 360 is 2.25. So we get 2.25 pi as our final answer. So the area of the sector is 2.25 pi. Number 27. I have yet to meet a teacher that can honestly say they covered Capillaries' principle in detail. It's a very simple concept, and many teachers touched on it, but many teachers were also surprised that they put this on the Regents. So, what is Capillaries' principle? Here's what it says. If in two solids of equal altitude, the sections made by planes parallel to and at the same distance from their respective bases are equal, then the volumes of the two solids are equal. So you can go ahead, read that again if it didn't make sense. Essentially, what it's saying is this. The area of the base here will be equal to the area of this base. And the altitudes are the same. All right? Those altitudes are the same. So it doesn't matter that this triangular prism is slanted. It will have the same volume as this prism. So if you want to use Capillaries' principle to explain why the volumes of these two triangular prisms are equal, we can say the following. Each prism has the same base area, and each cross-section is the same. Since the altitudes are equal, the volumes will be the same. So let me unpack this a little bit. Each prism has the same base area, and each cross-section is the same. So what that means is this. If you were to slice up both prisms, if you were to make slices out of them, all those cross-sections, all those slices, they would all have the same area. And since the altitudes are equal, then the volumes will be the same. Okay, that's the best I can do for now. So that's number 27. Number 28, when volleyballs are purchased, they are not fully inflated. A partially inflated volleyball can be modeled by a sphere whose volume is approximately 180 cubic inches. After being fully inflated, its volume is approximately 294 cubic inches. To the nearest tenth of an inch, how much does the radius increase when the volleyball is fully inflated? Okay, so a partially inflated volleyball. I guess if Tom Brady played volleyball, he'd like his volleyballs that way. No, I'm just kidding. I love Tom Brady, by the way. So the partially inflated volleyball, partially inflated, it's got a volume of 180 cubic inches. Okay? That's the partially inflated one. And then the fully inflated one, yep, it uses that terminology, fully inflated. What's it say? It's got a volume of 294 cubic inches. This question is looking at the radius, right? How much does the radius increase? So let's find the radius for each one, and then from there we'll be able to see how much the radius increased. So hopefully you'll remember, and I think it's also given in the back of the Regents, that the volume of a sphere is 4/3 pi r cubed. So to solve for the radius, we're going to plug in for the volume. We get 180 equals 4/3 pi r cubed. So we need to solve for that radius. So to do that, I got to isolate it. I got to get it by itself. So I got to get rid of this 4/3 here, and I do that by multiplying both sides by the reciprocal. Okay, so this is going to cancel out that. Then I have to divide both sides by pi to get rid of the pi here. So I divide both sides by pi. So the pi's cancel out here. And then I have to take the cubic root of both sides. Let me use a different color for that one. So then I got to take the cubic root of this, and then I got to take the cubic root of this whole thing right here. And then that will get me the radius. So let's get a calculator and do all that. So it was 180 times 3/4 or times 0.75. I got to divide that by pi, and then I got to take the cubic root of that. So there's a function in the calculator for that. So taking the cubic root of that, I get approximately 3.5 for the radius, and it wants it to the nearest tenth, so I can just go ahead and round it to the nearest tenth. So I get 3.5 for the radius of the first one. Hopefully you get the gist from this, what you need to do for the next one. Okay, what we need to do is, right, we first need to multiply that 3/4 by the volume, divide that by pi, and then take the cubic root of that to get that radius. So let's get our calculator to do that. So that's 294 times 0.75. Divide that by pi. And then let's take the cubic root of that. And we get approximately 4.1. So the radius for this one is approximately 4.1. So what's the difference in the radius? How much does the radius increase when the volleyball is fully inflated? Well, what's 4.1 minus 3.5? So what's this minus 3.5? You get about 0.6. So our answer to the nearest tenth, we're going to say about 0.6 inches, right? Is that rounded correctly? Yeah, about 0.6 inches. Okay, number 29. In right triangle ABC shown below, altitude CD is drawn to hypotenuse AB. Explain why triangle ABC is similar to triangle ACD. Okay, so here's my approach. We were told that this is a right triangle, so this angle ACB is 90 degrees. Then it says an altitude was drawn. We know that an altitude is perpendicular to the base. So that's 90 degrees. This is also 90 degrees. So we got three triangles there, three right triangles. Okay, this is my approach to this problem. Let's start off with triangle ACD, the little triangle. Let's start off with that one. That's this triangle right here, triangle ACD. Okay, and I'm just going to park that right over here. That's triangle ACD. Okay, we know this is 90 degrees. And then we have the big triangle, triangle ACB. So just stay with me for a moment. Okay, we got that big triangle ACB. I'm just going to go ahead and draw that here. So C is 90 degrees. A is going to correspond to A. And then this is going to be B. All right, that's this point right here, B. Now I want you to notice something. Did you notice that angle A is shared by both triangles? Angle A is congruent to angle A by the reflexive property. So that means these triangles are similar by the angle-angle theorem. So here's what I would write. Triangle ABC is similar to triangle ACD by the AA theorem. Angle A is congruent to angle A by the reflexive property, and they both have a 90-degree angle. So they're both similar by the AA theorem. That's my little explanation. Okay, number 30 says triangle ABC and triangle DEF are drawn. If blah, 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 write a sequence of transformations that maps triangle ABC onto triangle DEF. So we want to map triangle ABC onto triangle DEF. Let's visualize this. Okay, how can that happen? One thing I can do is I can rotate this triangle until AB is parallel to DE. So you see what I'm doing there? I'm rotating this until AB is parallel to DE. Once I get them to be parallel, I have a vector here I can draw. I can draw vector B to E, or C to F, or A to D. You just got to pick one. So I picked the vector BE. So once I rotate it until these are parallel, I can translate this triangle along that vector until B maps onto E. And then that makes the triangles map onto each other. So here's my explanation. Rotate triangle ABC clockwise about point C until AB is parallel to DE. Translate ABC along BE until B maps onto E. Number 31. Line N is represented by the equation 3x plus 4y equals 20. Determine and state the equation of line P, the image of line N, after a dilation of scale factor 1/3 centered at the point 4, 2. Explain your answer. Okay, so we're starting out with line N. So here's line N. And it's got this equation, 3x plus 4y equals 20. If you put this in y equals form, it's going to get you 4y equals negative 3x plus 20, and then dividing by that 4, we get y equals negative 3 over 4x plus 5. So that's the equation of line N. Now, what are we doing to line N? Well, it says that it's being dilated by a scale factor of 1/3 centered at the point 4, 2. So line N is what you're starting off with. Line P is what we're looking for. But how do we get from line N to line P? That's what it says. It says that line P is the image of line N after a dilation of a scale factor of 1/3 centered at the point 4, 2. So there are two things you need to remember when you're dilating a line in a coordinate plane. If the center of dilation is at the origin, you will only multiply the y-intercept. If the center of dilation is centered at the line, if it's on the line, then you will get the same exact line. So the question now becomes, is the point 4, 2 on this line? And one way that you can check that is just by plugging the 4 and the 2 into the equation. I would just plug into this one, to the original one. That's much easier. So if you plug in the 4 and the 2, you're going to get 3 times 4 plus 4 times 2 equals 20. Is this equation true? 3 times 4 is 12. 4 times 2 is 8. 12 plus 8 equals 20. This point is on the line. I just tested it. It is on line N. This point is on the line N. So line P will be the same exact line you started off with. So the answer is, you can say it's y equals negative 3 over 4x plus 5. Or you can even just give the original line. You don't even have to put it in y equals form. 3x plus 4y equals 20, because it's just said state the equation of line P. It didn't say in what form to do it in. So that's the answer, and they do want an explanation. So let's give them an explanation. So the explanation is, we get the same line since the center of dilation is a point on the line. That's the explanation we give. So I could have done this much shorter if I had just plugged in that 4-2 into the original line and see that the center of dilation is on the line. All I had to do is just write the original line and then write that explanation. But what happens if the center of dilation is not on the line? What happens if the center of dilation is about the origin? And I think I mentioned that earlier. You only multiply the y-intercept by 1/3, and that's your new line.